At this point, you should be able to do majority of P6-11 pretty much on your own. There's a few challenges here. We've covered most of the topics. Seems like we're pretty much revolve intensive on this one. So when we look at this, there is not a clear dimension. At least I'm not picking it up yet on this this end piece. Where the geometry comes down, so kind of make the assumption that that chamfer is gonna kind of fit in there somewhere. So we'll have to play with that one a little bit. Maybe use our section views to do a little visual on it. Other one is the chamfer on the hex. If we make a good decision in drawing the orientation of the hex, that certainly becomes a lot easier. Otherwise, we have to create an angled plane to work with that. And speaking of planes, when we come to the hole wizard, we'll look at one of these in the 3D sketch, and we'll look at one of these as making it with a plane and our geometry. So let's go ahead and get started. And we're going to pull up a standard part. If you have created your metric parts, then or your metric part template, then go ahead and use it. Switch over to millimeters, grams, and seconds. I'm in the front. Anytime I'm doing the revolve, my first instinct is to insert a center line, vertical, infinite length. We place that on the origin, and it doesn't really matter if you start at the top or the bottom. So we'll bring this out up to if you want to include the chamfer in the sketch, or add it as a feature. And I could also use the jog line to create these little notch outs. And we'll zoom out just a little bit. Alright, and I don't want to include the hex. That's going to be an extrude, boss extrude at this point. Turns gray, which means that I got it successfully closed in. And I'm going to control select, got a midpoint. So I'm going to bring those out and make them collinear. Both of the undercuts are 15 millimeters, so those will also be collinear. Or, just to run back through the relations, if I was to pick a point in a line, then that would be coincident, and if I was to pick 2 points, that would be vertical. So if we go, any one of those will work. And I'm just kind of staying consistent with the collinears in the way that I read the relations. All right, so we have 20 millimeters on the body. We have an overall of 73 to the top. So -5 will give us 68. From the, well, we're going to end up doing some math here, so let's include a little bit of geometry to help with this this calculation. So doing the bottom one was 23 millimeters from the face. 3 millimeters for the chamfer. We're going to go 45 degrees off of the bottom of the part. 15 millimeters on the undercut. And then, since I'm in diameter, I'm going to see that little icon. If I recognize it, I can hit escape, or if I apply it and I get the diameter and didn't really want it, I can hit escape on the keyboard, and that will bring me back. 5 millimeters on the groove, 5 millimeters, 2 grooves, huh? And they're putting an M6 in there. Yeah, I don't know about that one. We'll have to see how those fit. All right, so design intent is that both of those will be 5 millimeters, so we'll set them to equal. That way, if I do need to make a change, I can change one dimension and get both of them. So I'm just going to create another center line, make the endpoint coincident, and then set it 5 millimeters from the top to mimic the head. Alright, so on occasion I've been able to grab the handle and reposition. Most of the time I would just go ahead and delete it and reapply it. So 73 from the top, 5 millimeters down to the head, 25 millimeters now from my head reference to the top of the groove. That gives me the geometry. And you can do the math and you know, really, if we're designing this off of the top of our heads without reproducing a model, I'm gonna build this in what makes sense and dimension it in what makes sense as I'm going through the process. So I have my fully defined sketch. I'm going to go into the features and revolve, or if you added to the customize, which this one's not really squaring itself out. There we go. Let's go that route. So once you're in the customize, you can drag this around a little bit and make it a little bit more functional. Alright, so I want my revolve. If you haven't created that one, just go up to the command manager and revolve. Now we're in a situation where I have two center lines. If I were to pick this one, it would create a revolve around the horizontal. I want it revolved around the vertical. So we go ahead and make that pick. I want a 20 millimeter cosmetic thread. Right, so and we can go up to Tools or Insert, Annotations, Cosmetic Thread. If we customize and drag one out, or if we go over to the commands and start to type in cosmetic thread, that will take me into the loop. We're going to pick up an edge, and type is machine thread. The other option was a pipe tap. Haven't done too many M20s, so let's just go with a 2 millimeter. 2.5 is about 100 thousandths, so that would be fairly coarse. 2 millimeters is about 80 thousandths. I always, since I think in thousandths of an inch, I always do that quick conversion. Think about what I'm telling it to do. Up to next, we'll go to the undercut, which is fine, and we'll go ahead and accept. I'm going to kind of see the minor diameter in the angle, but when I go to the front, then I'll be able to pick up those geometries. Alright, so on the top plane, we'll open up a sketch. We'll go into the polygon. 6 side is already there. Inscribed is the interior, circumscribed is the exterior, so touching on the flats, touching on the points. Alright, so if I grab it this way, and it's not really going to make that big a difference. It's just going to be in my choices. I'm going to have a harder time generating that little angle on this side, but as long as one of them goes through, one of the axes goes through the, in this case, what would be the front or the right plane, then we'll have the same result. So selecting the origin, selecting a point, we'll make that horizontal. My across the flats is 25, so the inscribed circle. Okay, find a place to place that. There we go. And then, if I wanted to, we could put the show the sketch, and that gives me a location from that original sketch to drive up to. So features, extrude, and this would be a place where I could use up to vertex. That endpoint represents vertex and gives me the geometry. Alright, so that's looking pretty good. We need to put the angle on. And nothing wrong with just telling it to do the extrude to 5 millimeters and ending up with the same result. Alright, but going back to some of those techniques in the multi-body and the top-down is trying to be able to find a single location to make these adjustments from. Alright, so we go into the front plane. This is going to be a cut revolve. So center line, vertical, infinite length. We'll set it on the origin, goes fully defined. I'll do L on the keyboard, and we'll draw our angle. And there's no specific dimension, so we'd either assume maybe 45 degrees or 30 degrees. Let's go with a 45 degree. That'll look pretty good. And if I go to the diametral dimension, I want it to disappear when it comes around to the flats. Okay, so that's going to cut the well, I'm going to have to see. I may have taken a little too much. No, it'll disappear at the flat. So feature, revolve cut, accept. Now we have the angles at the outside. Alright, so that gives me all of my geometry that I need for this part. Let's go ahead and save. We're going to go back up, create our new folder, P6-11. And we have another screw type, so we'll go ahead and give it a name and one quick check. I think we're good.